Dr. Lee Berger, paleoanthropologist and National Geographic explorer in residence, describes why the human family is so vast and complicated. In the video, he describes how the science behind ancient human remains has changed from simple dating to more broad and complex relations. He will discuss how we differentiate our species, Homo, from some more primitive species, like Australopithecus.
So that used to be a really easy answer, the idea of what is Homo and what's Australopithecus. And if it were 10 years ago or so, I'd answer that very quickly about different morphological characteristics that clearly define the two groups. But in the last decade or so, largely because of the discoveries I've made, a lot of them right here, it's become a lot less clear of what exactly is the definition of Homo and what's the definition of Australopithecine. Typically, the way that we are broadly looking at it is that Homo is a grade that is largely the adaptation that we humans have, and tends to include things like a larger brain, encephalization, a adaptation with tools, and the reduction in tooth size, and changes like that.
So when you say larger and reduction, is there a standard line? How do we decide what's larger and what's...
All of that's the big problem right now, because what has happened in the last decade is we've discovered species that violate that completely. One of them is Homo naledi, which was recovered right here, which is a species when you first look at it, and when lots of scientists first looked at it, thought it should be 2 to 3 million years old, because of its anatomy, because it had a tiny brain. It has morphology that looks a lot like an early Homo erectus or a Homo habilis or things like that, which typically you would put back at 1.9, 2 million, maybe even 2.5 million years old. But had characters of it that look much later too, that you would see in more derived or advanced species like humans. It's this mosaic or combination of features, and of course it exists very late in time though. Only say 200,000 to 300,000 years ago. And so it's species like that which have caused us to pause on the easy answer of, in what genus you are, and also begin, I think a lot of us are beginning to ask, are those really useful terms? Is it that important to divide these things up? Because what we're finding is that old t-shirt model of human evolution, the idea that, one species gives rise to another, gives rise to another, gives rise to another, ever advancing towards modern humans, that's just simply not true. That's not how the evolution of our species has worked. And also the idea that as each of those events happened, the older model goes extinct in the way, an old model of car, is no longer in vogue. You can tell how old a car is by looking at it. Well, that's what paleoanthropologists used to do 20 years ago. We used to look at a fossil and knew how old it was. You can't do that anymore because of the discoveries that are being made here and in fact across the world. What we're finding is that species survive beyond that moment of the evolutionary building of a better mousetrap, if you use it in those simplistic terms. That happens. And secondly, there's a lot of what we call introgression. What that just means is they have sex with each other and they interbreed with each other and they share genes, and that morphology gets mixed up and it comes from the past and injects itself into the later forms, and the later forms then adapt and evolve, and then they mix together, and it's this big mess. And we're right in the middle of a period where firstly, maybe for the first time in history, understand it is a mess. And we're in that moment right now. And so what used to be a neat ladder-like story where I could tell you, well, Australopithecines give rise to Homo, and then I could break that in time to different species. I could tell you how each one was related to the other. We can't do that anymore. That's the one thing we know right now. And that's actually science. That's how science is supposed to work. We had always used a sort of human exceptionalism. The idea that humans were different from every other animal in the world, because every other animal we know works like that. All you got to do is look out at the African wildlife and you can see the sort of grades and relationships. These clusters of animals are clearly related to each other, and then you get different groups. Antelopes are a perfect example of that. where you get things that are closely related, and then you can see things that are very distant from each other. We thought humans were just this one sort of lineage. We now know that's not true.
As Dr. Berger explained, the pedigree of the human family is not simply linear. It is complex and not well understood. Today, many paleoanthropologists like Dr. Berger are adding to our understanding of the human family.